We are going to start out our unit on elections by talking about plurality, which is arguably the simplest of the voting methods, and Condorcet. So first of all, in a democracy, an election is a method by which the many and often conflicting choices of individual voters are sifted so that a single choice representing the collective voice of the group can emerge. Voter theory is the understanding of the intricacies behind the process. So that's what we're going to be talking about in this unit. And probably the most important thing to keep in mind as we go through this unit is a discovery by Kenneth Arrow. In 1952, he discovered that there is no consistently fair democratic method for choosing a winner, and created Arrow's impossibility theorem, which says a voting method that is democratic and always fair is a mathematical impossibility. So as we go through this unit, we're going to look at a few rules that mathematicians and social scientists have agreed upon as rules of a fair voting method. And we are going to show that every method that we have for voting violates at least one of those rules. So, first, we're going to look at preference ballots and preference schedules, which are a way of organizing our information so that it is much easier to analyze. So first, let's look at the Math Appreciation Society, which is holding its annual election for president, and there are 4 candidates: Alicia, Boris, Carmen, and Dave. We're going to abbreviate them A, B, C, and D. Each of the 37 members of the club votes by means of a ballot indicating his or her first, second, third, and fourth choice. So we're going to look at these ballots to determine the winner. So, some essential ingredients of every election are a set of voters and a set of candidates or choices. So, in this unit, we will be using preference ballots, where voters are asked to rank the candidates in order of preference, and we are going to be using linear ballots, where ties are not allowed. Now, I know that preference ballots are not normal in American elections, but using a preference ballot does give us all of the information we need for the voting methods we're going to look at. So instead of having to collect information, do some analysis, collect more information, do some more analysis, doing a preference ballot allows us to collect all the information we need up front, and then we can follow through with whichever voting method we're looking at. So, looking at the ballots submitted for the Math Appreciation Society election, there are many repeats. So, if we have 4 candidates, there are 4 factorial different possible preference schedules, which is 24. There are 37 members, only 24 possible rankings, so we are going to have some people who agree on the rankings. So we can organize all of these ballots by grouping them together by the identical ballots, and we're going to create a preference schedule. Which is a list of possible outcomes in the order a voter most prefers them. So, this is an example of a preference schedule for the math election. And here's the way you read this. There are 14 people who voted in this order, A, B, C, D. There are 10 people who voted in this order, etc. So, a couple of facts about preference ballots. So first is you have transitivity of individual preferences. So these 14 people, A is their first choice, B is their second choice, C is their third choice. They like A better than B, they like B better than C, so they like A better than C. That's the transitive property. And the other thing is, preference of voters are not affected by the elimination of one or more candidates. So let's say that candidate C decides to drop out of the race. All you do is scribble out all the C's, and the rest of the orders stay exactly the same. So, first method we're going to look at is the plurality method. So in the plurality method, the only thing we care about is which candidate has the most first place votes. And that person is called the plurality candidate. So we don't even care about the second, third, and fourth choices. We only care about the first place votes. So let's go through and count up how many first place votes each of these candidates gets. So candidate A has 14 first place votes. Candidate B has 4. Candidate C has 10 plus 1, so 11. Candidate D has 8. So who is our winner? Candidate A or Alicia. So she wins the Math Appreciation Society election. Now, plurality is how most of the elections in the US for political office are decided. In a democratic election between two candidates, the candidate with the majority means more than half of the votes, should be called the winner. I'm going to pause here and note the difference between plurality and majority. Plurality means you have the most votes. Majority means you have more than half of the votes. So, if someone gets more than half of the votes, they should be the winner. This is called the majority rule. And the winner is called the majority candidate. Now, there are some problems with the majority rule. So, if you have more than 2 candidates, you might not have a majority candidate. The other issue is that it only takes into account your first choice. It does not take into account who would be your second or third, etc. choice. So the majority rule is one of those rules that I mentioned that people have decided is a rule of voting. If you have a fair voting system, it should follow the majority rule. The candidate who gets more than half of the votes should be the winner. Now, we have the majority criterion, which says if candidate X has a majority of the first place votes, then candidate X should be the winner of the election. Now, the plurality method always satisfies this criterion, because if someone has the majority, then they are going to have the most votes. But not all of the voting methods that we look at will satisfy this criterion. If a voting method does not satisfy this criterion, we say that it is violated. Now, it is the method, not a particular election, that violates the criterion. If a specific method violates the criterion, it just means that it's possible that the person who gets the majority of the first place votes would not win. It does not mean that every time you apply that method that someone who gets the majority of the first place votes won't win. So we are going to look at another criterion that is considered to be a rule of fair elections. And this was put forth by the Marquis de Condorcet, who is a French mathematician, philosopher, economist in the 1700s. And he was a friend of Borda, who we will get to in the next video. The Condorcet Criterion says if candidate X is preferred by the voters over each of the other candidates in a head-to-head comparison, then that candidate should be the winner of the election. And that candidate would be called the Condorcet candidate. So let's look at an example of this. So we have the University of Tasmania Marching Band. They are so amazing that they've been invited to perform at 5 different college bowl games. The Rose Bowl, the Hula Bowl, the Fiesta Bowl, the Orange Bowl, and the Sugar Bowl. We've abbreviated all of those using their first initial. The election is held among the 100 members of the band, and we have the results here. So first we're going to look at this with plurality, and then we'll look at this using the Condorcet method. So remember, plurality only looks at first place votes. Which bowl game has the most first place votes? That is the Rose Bowl, or R. Now, let's look at the Condorcet winner. So for Condorcet, you want to look at head-to-head matchups. And I've told you here that there are 10 head-to-head matchups. The way you can figure that out is however many candidates you have, choose 2. So that's how many head-to-head matchups we'll have. So I'm going to list out all of those matchups. So I have Rose Bowl versus Hula Bowl, Rose Bowl versus Fiesta, Rose versus Orange, Rose versus Sugar. I have Hula versus Fiesta, Hula versus Orange, Hula versus Sugar, Fiesta versus Orange, Fiesta versus Sugar, and Orange versus Sugar. So those are my 10 head-to-head matchups. So if I want to look and see the Rose Bowl versus the Hula Bowl, basically I'm going to ignore all of the other options and just look at Rose versus Hula. So in this first one, Rose Bowl was better, or was preferred. So there are 49 votes for Rose Bowl. 48 people preferred Hula over Rose, and these 3 people preferred Hula over Rose, so that means 51 votes for Hula. So in this matchup, Hula Bowl wins in that head-to-head matchup. So that's what we're going to go through and do for all of these head-to-head matchups. If you need to draw on the preference schedule to help you do that, that's fine. If you can do that without, that's fine as well. Then we want to count up how many head-to-head matchups each choice won. So you can see the Rose Bowl won 0 head-to-head matchups. The Hula Bowl won 4 head-to-head matchups. Fiesta Bowl won 3. Orange won 1, and Sugar won 2. So in this case, the Hula Bowl won all of its head-to-head matchups, so it is the winner. Now, the plurality method violates the Condorcet criterion because we have a Condorcet candidate. We have the Hula Bowl that won all 4 head-to-head matchups, but did not win via the plurality method. The other thing is, the issue with the Condorcet criterion is you might not have a winner, because you only have a winner if someone wins all of their head-to-head matchups. So let's go back to the Math Appreciation Society election. We want to first copy down our results by plurality. Alicia was the winner. Now let's figure out the Condorcet winner. So we have 4 candidates. So we have 4 choose 2, which is 6 head-to-head matchups. So then we need to count the number of head-to-head matchups that each candidate won. A lost all of them, B won 2, C won 3, and D won 1. So candidate C, which is Carmen, won all of the head-to-head matchups. So Carmen is the winner via the Condorcet method. Now, you remember how I mentioned that there are issues with every single voting method? Well, the issue with the Condorcet method is called the Condorcet Paradox. That means that group rankings may violate the transitive property. So if 20 people rank their preferences A, B, C, 20 have B, C, A, 20 have C, B, A, and I go through and do all of the head-to-head matchups. A versus B, A versus C, and B versus C. So 20 people prefer A to B, this one is B to A, this one's A over B. So this is 40, this is 20. So A is the winner there. A over C, C over A, C over A. This is 40, 20. And then B and C. I have 40, 20. So if it was just A and B, A is preferred. If it's A and C, C is preferred. If it's B and C, B is preferred. And there's kind of this circular little reasoning. They prefer A over B, prefer B over C, and then prefer C over A. So the group rankings are not transitive. But things to remember, an individual voter's preference is transitive. and the relative preference of voters are not affected by eliminating a candidate. Last thing to talk about today is insincere voting. I'm just going to note that this is individual voters. Insincere voting is also known as strategic voting, and it's when you feel like your candidate that you really like doesn't have a chance of winning. So instead of wasting your vote, you go for your second choice or maybe your third choice, someone that you think has a better chance of winning the election, which is fairly common in US politics. Most people know that Democrats and Republicans are more likely to win an election than third-party candidates. So a lot of voters, even though they might agree with the Libertarian Party, the Green Party, an independent, another candidate, might still choose either the Republican or the Democratic candidate because they believe that that candidate has a better chance of winning. Another form of insincere voting is legit cheating. So that's it for today. We will look at a couple more voting methods in the next video.